The sensor network that I presented in the week 4 was Pinpointer, which is a counter-sniper system that utilizes muzzle blast and shockwave in order to detect multiple shooters at the same time. Nodes record the signal and send back to base station, where fusion algorithm is applied. The wireless protocols used were RIPS, FTSP, and DFRF. One of the security issues that Pinpointer is susceptible to is jamming because of DFRF protocol. Jamming is the transmission of radio signals having the same frequencies as being used by the wireless network and can cause permanent or temporary suspension of message reception and deterioration in effectiveness of many neighboring nodes. The fundamental problem in FTSP is that it allows for any node to elect itself the root after a period of time of not receiving the synchronization information. A corrupt node could claim itself to be the root, and now the other nodes will respond to its timing information instead of the correct information from the real root node. This will of course propagate through the network until all the nodes have incorrectly calculated their skew and offset. RIPS does self-localization of modes by utilizing the radio interference created by two simultaneously transmitting nodes, but it is susceptible to RF multipath that could be caused by various atmospheric factors, resulting in noise, distortion, or attenuation. The DFRF protocol in pinpointer systems uses the gradient converge cast policy, in which all the data is eventually sent to the root node. It consumes significant amount of message overhead as the number of transmissions to route a single data packet can grow as the square of the distance between the sender and the root. Nodes in Pinpointer can be physically attacked by extracting cryptographic keys from the captured nodes, tampering with its circuitry, modifying the program codes, or even replacing it with a malicious sensor. It has been shown that sensor nodes such as Mica 2 modes can be compromised in less than 1 minute time. Since sensor nodes in Pinpointer have IDs assigned as their identity by virtue of DFRF protocol, an adversary can add new malicious node by copying the ID of an already existing node. By using the replicated node, packets arriving through it can be dropped, misrouted, or altered. This results in incorrect contents of information packet, loss of connection, and high end-to-end latency. One of the biggest faults to Pinpointer is that using FTSP creates a lot of unnecessary overhead, hence no power management because each node must be on and active at all times as time sync messages are being sent continuously. Therefore, each node can never be allowed to enter sleep mode or else the potential for a time sync message to be lost is greatly increased. This could cause massive clock skew within the network and all data received by the base station could no longer be trusted as accurate. One of the solutions to avoid jamming is spread spectrum or code spreading. In these methods, several frequencies are utilized for transmission. The simple jammer is usually not capable to jam wide band of frequencies or switch to exact frequencies. Jamming attacks can be characterized by high background noises, which can be reported by the neighboring nodes. Then a deviation in routing paths can help in avoiding this attack, or the sensor nodes under attack can be put to sleep for a long time. Low duty cycles can be applied to consume less power, which gives the node the opportunity to try to connect to sensor network once the attack is over. Another efficient yet costly solution is the alternative use of optical or infrared communications. Camouflaging and hiding sensor nodes are countermeasures against physical attacks. Modes which handle critical data can use any erasure procedure which makes them remove any critical information, that is cryptographic keys or codes, when they are tampered with. Better method for converged cast message routing is the spanning tree algorithm. While the gradient converged cast policy uses a single path starting from the source to the node, the fast method uses only a small neighborhood on this path to send data in form of spanning tree, therefore saving on network congestion. The graph shows network usage in both the methods, and it can be clearly seen that the spanning tree method is more efficient. For FTSP, redundancy could be introduced so that it does not calculate its timing from just one neighbor but from several. It could then determine if there is a corrupt node. If a node was suspicious that it was receiving bad synchronization data, it could cease retransmission of the data. This would stop the desynchronization from propagating throughout the network. In order to improve power performance of FTSP, RITS should be implemented. It is an implicit time synchronization protocol, that is, the time synchronization is done as a part of the regular message routing, not as a separate protocol. This means that the modes will only synchronize their global time variables when they transmit or receive data, that is, after a short event has occurred. The disadvantage of Pinpointer is its static nature, issue of scalability, and the need for many sensors. Hence, a soldier variable version could be developed that requires only a handful of sensors. Venerable team is working on mobile phone based approach where the smartphone would carry out the fusion algorithm by taking use of the microphone, a GPS, Wi-Fi or 3G networking, and a display. But the team says would not be too accurate, and continuous sampling of the microphone would drain the battery fast. Instead, developing a custom Bluetooth headset that doubles as a single channel sensor node, which then utilizes that phone when there is a shot detected, could serve as a better option. Thank you.